Okay, a couple U-substitution problems. The first one here, we've got the integral of natural log, or ln, of x to the 10 over x dx. Okay, so with U-substitution, we have to pick something in this problem to designate as u, so that we can make this problem simpler for ourselves, do the integral, and then plug u back in when it's easier at the end. So the way that we do that, one way to pick u is pick the most complicated thing in the integral so that you don't have to deal with it. In this case, it's natural log of x. We're going to say u equals natural log of x. Once we've, dx. So we always write that, and then we have to take the derivative of u, which we always call du. So we say du is the derivative of natural log over x, which is 1 over x. And actually now, I'm remembering dx only comes in down here. So we decide what we're going to do for u. It's natural log of x. Then we take du, the derivative of this. The derivative of natural log of x is always 1 over x. And then we add dx in because what we need to do is solve this equation here for dx so that we can plug back in. So we're going to go ahead and do that. We're going to multiply both sides of this equation by x, so we get du times x equals dx. Now that we've solved for dx, we can go ahead and plug back in. So this integral is going to become the integral of u to the 10, because remember we designated that u would stand in for natural log of x, so we plugged u back in, and then we have over x here. And then we've solved for dx, so we can actually plug in du times x for dx now. So we're going to go ahead and put that in there, du times x. Now that we have plugged everything in, we can go ahead and simplify this and then solve. The basic, the end goal of U-substitution is to get to the point where you have only u's in the integral. So we need to, and that can help you decide what to substitute for u here, because you need to get to the point where all of the x's disappear out of the integral. In this case, it works because when you plug everything back in, you've got an x in the numerator and an x in the denominator, so these cancel, and you're left with u to the 10 du, which is really easy. So now that these are gone, we can take the integral of u to the 10 du. The integral, of course, is u to the 11, and then we have 1/10. And the way that I did that is you divide the coefficient. This is 11. You add 1 to the exponent, so 10 plus 1 is 11, and then you divide the coefficient, which is 1 here implied, by the new exponent. So we have 1 over 11, u to the 11, the du drops away, of course, and then plus c, we always have to add back in for a constant when we're taking the integral. So this is the answer in terms of the fact that we found the integral. Now all we have to do is plug back in for u. So u, we said, would be natural log of x. So our answer is 1 over 11 times ln of x to the 11 plus c. And that's it.